So if you came up with 3 halves r plus 1 over 4r to the 1 half. All right, so again, the big thing is now that you have product and quotient rules, just because you see a product, just because you see a quotient, don't forget about how you handled problems last night for homework. Take the easiest route if possible. If you can, use that power rule over product and quotient rule. All right, any questions on that? All right, let's take a look at another example, our favorite tangent line problem. So we want to find the equation of the tangent line. So again, we're looking for the equation of a tangent line. So anytime we see equation of a tangent line, what 2 things do you always have to know? You have to know what? Point and a slope. So we still have to know those 2 things. They're given the function square root of x over x plus 1, and we want to find the equation of the tangent line at x equals 4. Let's talk about the point first. So at x equals 4, 4 is my x coordinate. How do I find the y coordinate? Plug 4 where? Back into original function. So f of 4 is equal to the square root of 4 over 4 plus 1. So what is f of 4 going to be equal to? 2/5. So now I know my point. Now when I take a look at trying to find the slope, I know I have to find my f prime of x. So I have square root of x divided by x plus 1. Notice your denominator is a binomial. You cannot take and divide out the x plus 1. You're going to have to use your quotient rule to find f prime of x. So again, remember your quotient rule is f prime g minus fg prime, square the bottom, and away you go. So again, remember your numerator is f, the denominator is g. So again, I need to identify my f, f prime, g, and g prime. So f is the numerator, which is square root of x, which I'll write as x to the 1/2. G is the denominator, which is x plus 1. So now I need to find f prime and g prime. So what is the derivative of x to the 1/2? We've done this how many times now? A lot. That's why it's one of those common ones that's easier just to remember because it comes up all the time. So it's going to be 1 over 2 x to the 1/2 for square root of x. You can leave it as x to the 1/2 if you want, or just write it as square root of x. What is the derivative of x plus 1? 1. So there's your g prime. So now to find my f prime of x, I have to plug what I know into my quotient rule. So f prime we found to be 1 over 2 square root of x. G is the denominator of x plus 1. So there's my f prime g. Minus f. F is the numerator, which is just the square root of x, or x to the 1/2. Times g prime, which is 1. All over the denominator squared. Any questions on that? Now remember, what are we trying to find out of this? We're trying to find the value of this derivative at x equals 4. Before you get in all your fancy algebra stuff, most of you like to deal with numbers rather than variables. So at this point, go ahead and find your f prime of 4. Plug in the 4 for x. Simplify with the numbers. If you're trying to find the value of the derivative at a particular x value, it is easier before you simplify. There's no need to simplify that derivative. Go ahead and plug in the value for x. So we have 1 over 2 times the square root of 4 times 4 plus 1 minus the square root of 4 all over 4 plus 1 squared. Well, what is the square root of 4? Let's start with 1 over 2 square root of 4. Square root of 4 is just what? 2. So 1 over 2 times 2 is going to give me a what? 1/4. So 1/4 times 4 plus 1, which is 5. Minus square root of 4 is 2. All over 4 plus 1 squared. Well, 4 plus 1 is 5. 5 squared is 25. 1/4 times 5 gives me 5/4 minus 2 over 25. That's why I said what you're doing is you're simplifying with the numbers versus spending the time simplifying with the variables. Okay? This is a complex fraction. You've simplified complex fractions before with variables. You can do the same tricks with numbers. Multiply everything by the LCD of 4. So just multiply everything by a 4. 5 fourths times 4 is a 5, minus 8 over 100. Much quicker than getting common denominators, subtracting, then multiplying by reciprocals. Use that complex fraction trick. 5 minus 8 is what? Negative 3. So negative 3 over 100 is your slope. Now you know your point. Now you know your slope. You can write the equation of your tangent line. So y minus 2/5 is equal to negative 3 over 100 times x minus 4. All right. Questions on how I found that one? All right. Do a quick review. Parallel lines have what? What kind of slope? Same slope. Perpendicular lines have what kind of slopes? Opposite, reciprocal. Because sometimes what they want you to do is they want you to find tangent lines that are perpendicular and parallel to other lines. So just don't forget, if they want you to find a tangent line parallel slopes are equal. So we should be able to find the slope, and then you're just going to set the derivative equal to that particular slope. Perpendicular lines are negative or opposite reciprocals. So again, find the opposite reciprocal of the line that you're trying to find it perpendicular to, and then find the value of the derivative at that point. Remember, normal and orthogonal and perpendicular all have the same meaning. So again, we talked about this back in our vector unit. Normal, orthogonal, or perpendicular. Sometimes they may ask you to find the normal line. It's the perpendicular line. Sometimes they ask you to find the orthogonal line. It's the perpendicular line. So for example, let's take a look at this one. Find all the values of x at which the tangent line is perpendicular, which is normal, to the line y equals negative x. Well, first of all, identify the slope. What's the slope of this line? Negative 1. So for a line perpendicular to this, what would the slope be equal to? 1. So what I'm simply going to do then is I'm going to find f prime of x and set it equal to 1. They're not asking me to write the equation of the line. They're not asking me to find just the slope. All I need to do is find what x values. What are the x values? So now what I have to do is I have to find my f prime of x first. So looking at x squared over x minus 1, do I have to use the quotient rule? Yes. So again, my f is my numerator, g. See if you can set it up. See if you can plug the correct things into your quotient rule. So f prime g minus fg prime, square the bottom, and away you go. So substitute into that quotient rule first.